Today, I'll be talking about the Euler's method. We can actually derive the formula by looking at the graph drawn on the left. So we'll plot the y and x-axis first, and then we'll draw the curve using the formula given dy dx equals to x over y squared. And then we'll draw a tangent line at xn and yn, which is the starting point. Then we will plot the next point which we would like to find, which is the xn plus 1 and yn plus 1. The length between xn and xn plus 1 is h, which is the step size. The Euler's method is all about finding yn plus 1's approximate, which is here, over here. So, to find the approximate, we start by looking at the formula given. Y equals to fx, dy dx equals to f prime x, which is also known as the rate of change. So, in order to find z over here, we use f prime x equals to z over h, which is also known as rise over run. Rise over run is equals to rate of change. So, your z, in this case, your z here is your rise, and your h here is your run. Then, if you multiply this whole equation by h, you will actually get z equals to h times f times x. Then, in order to find yn plus 1, the approximate, you can actually use yn plus z over here to get the approximate over here. Then, you can actually sub in the equation from here into here. Then you get yn plus 1 equals to yn plus h times f prime x. The three columns are xn, yn, and f prime x. The first two values of x and y is actually given by the question where they say y times 0 equals to 1. This also means when x is 0, y equals to 1. My step size is shown over here, it is 0.1. So to find xn plus 1, I use the formula xn plus h, which is my step size. The formula in the Excel is shown like this, where I take the previous value of x plus 0.1. For yn plus 1, I use the formula over here where yn plus 1 equals to yn plus h times f prime x. So the formula in the Excel is shown like this, where I take the previous y value plus open bracket 0.1, which is my step size, times the previous value of f prime x. So for f prime x, I use the formula given by the question where they say dy dx equals to x over y squared. So the formula in Excel is shown like this, where I take the symbol value of x divided by the symbol value of y squared. So I use the power function in this case instead of the arrow up symbol, because the arrow up symbol is meant for a constant number, while the power out function allows me to change the value inside here. So to find y actual, we first apply first order ODE to the equation given dy dx equals to x over y squared. To do that, bring the x over to one side and the y to the other, and integrate both sides to get 1 over 3y cubed equals to half x squared plus c. Then, to find constant c, we sub in the equation y times 0 equals to 1. We should then get c equals to 1 over 3. Then, sub the c back into the equation that we just got to find y in terms of x. We should then get y equals to open bracket 3 over 2x squared plus 1 close bracket to the power of 1 over 3. Then, in order to solve the question, we sub in the value 1, which is the x value, to get the answer 1.357. The area margin shows the difference between y actual and the y approximate. If you look at the Excel sheet over here, there is two different step size. The one with the smaller step size has a smaller error margin than the one with a bigger step size, showing that the smaller step size provides a better y approximate. The graph on the right shows the example of how a smaller step size can have a smaller error margin. Thank you.